Units, prefixes, and scientific notation. What you really need to know. Why do we need units? We like to make a model of our universe. That's what physics is all about. To do that, we need physical quantities. We define those physical quantities by either how they are measured or how we derive them from other units. These units standardize values so that we can talk to each other in the same language, across countries and across time. In science, we use the metric system, which you might usually see as SI. There are 4 fundamental units in the metric system. The unit for length is a meter. We abbreviate that as a lowercase m. The fundamental unit for time is a second, which we write as a little s. Here's the tricky one. The fundamental unit for mass is a kilogram, which we write as kg. This is tricky because this is the only one that has a prefix. Please remember that. Okay, last one, the fundamental unit of electric current, which we will study next semester, is an ampere, which we write as a capital A. You might also hear this one called amps. If you look at the fundamental units for length, mass, and time in that order, you'll notice that they say MKS. Okay? When in doubt, you can always remember that your fundamental units are MKS. You may also see this written sometimes. Okay, what do we measure with these? We can measure a proton, a grain of sand, or the whole universe. The diameter of a proton is about 10 to the negative 15th meters. A grain of sand is about 10 to the negative 3 meters. And the distance from the Earth to the edge of the known universe is roughly 10 to the 26th meters. That's a lot of zeros. All right, so that's a huge range. So scientific notation, which is kind of what you saw on the slide before, allows us to express orders of magnitude. Orders of magnitude just tell us how many factors of 10 there are. So 10 to the second is 10 times 10. If it's a negative exponent, it just means it's a number less than 1, but it still gives you factors of 10. So 10 to the negative 2 means you take the inverse of that previous number. So it's 1 over 10 times 10. So in this case, it would be 1/100th. So another way to say it, So with kilograms, I mentioned they have prefixes. So prefixes allow us to write an order of magnitude without having to put a number on it every time. Some of these are familiar. Your computer hard drive is probably some number of gigabytes. But some of these prefixes are kind of exotic. The distance that light travels in a century is about an exameter. All right, so you may not have to remember all of these, and sometimes you can look it up. This is table 1.2 out of your OpenStax textbook. These are the metric prefixes for powers of 10 and the symbols that go with them. You'll notice that for 10 to the 6th and above, they're all capital letters. Everything else is lowercase. The one that has 2 letters there, deca, we probably won't ever use. All right. I want you to look down about 2/3 of the way down the table at the word micro. That little symbol next to it, that's mu. It's a Greek letter. Okay? If I had to pick the most important ones out of here, I would say kilo is important, centi is important, milli, micro, and nano. If you know those ones, you'll know most of the ones that you use in your standard physics class. All right, in summary, there are 4 fundamental SI units: length, time, mass, and electric current. We use scientific notation for orders of magnitude, and to simplify the notation, we sometimes use prefixes.